We are the water team, and our title is The Raindrop Effect. Meet the team. As a society, we are reliant on the media as a way of acquiring knowledge and updates about the current state of our country, and Hatfield is no different. For the last few years, we have been told how water scarce Hatfield is and how we should use water sparingly. But we want to ask the question, is Hatfield really as water scarce? The current state. Considering wastage, we first look at Tshwane as a whole. We learn that 88% of the water is imported. Of the total water available for Tshwane use, 44% is lost due to leakages and or mismanagement. And if we look at personal water usage, 65% of the water we are able to use goes to grey water. But if we start looking into the monthly rainfall of Hatfield alongside the 9 month economy and fluctuating temperatures, we ask ourselves if this is not a possible resource to be tapped into.
The majority of stormwater runoff is flushed into rivers, which carries it out of Hatfield. In some cases, water is captured and stored for irrigation purposes, such as UP's Javits Arts Centre and Pretoria Boys High School. All of Hatfield's yearly water needs could be provided from its own stormwater, twice.
So if we look at a typical month like January, we can calculate that we receive about 8,13 millimeters of rain per day for 13,3 days. And during those days, due to Gauteng being a medium evaporation ratio zone, we lose just more than 50% of water to evaporation. Based on the amount of residents and the average water usage per person, Hatfield uses about 1,286 megaliters of water annually. But if we take an annual rainfall, evaporation, and additional loss into consideration, we can clearly see that the pedestrian areas of Hatfield still receive more rainwater annually than the need. And the total area of Hatfield has the potential to generate twice as much water than the current need. The water cycle goes beyond the surface, and in order to look at our site's water situation holistically, we need to consider groundwater as well. In addition to rainwater, we have groundwater which forms part of the water cycle. The springs of Pretoria have supplied water for the past 160 years since the city was founded, and if managed properly, they can continue to do so. However, unmonitored and unregulated abstraction of water resources can result in significant ground instability and endanger spring and river flows. Most highly urbanized areas have fair to poor conditions, and our site falls in one of South Africa's stressed catchment zones with strained water resources. Based on our previous analysis regarding water movement patterns and water usage patterns, we can conclude that during the months with the heaviest rains, the largest population of Hatfield, the students, are not in Hatfield. The water streams on Hatfield are therefore perceived to be devoid of life during most months of the year. In a more natural stream setting, wider riparian zones act as buffers which allows water levels to rise and fall depending on the season, and users are able to visually interact with different ecologies throughout the year. Water enhances spaces, encouraging the creation of communal areas. Based on our survey, we have come to the conclusion that currently there are only around 3 public spaces that contain water features for the users in Hatfield to interact with. Access to the best quality third places are limited to private institutions and residences which are able to regulate and maintain these areas. This leads to the perception of lack of accessible spaces where water is well maintained feature.
In 2024, Urban Strategy Studio mapped 831 water points throughout Hatfield, the majority of which is fire hydrants. This map shows that there are no water points which is free, safe to consume, or easily accessible by the public.
We engaged with stakeholders via an unofficial question and answer session. UP Facilities and Hatfield CID are the institutions which have the largest influence on the holistic perception of Hatfield. UP owns roughly 60% of the land in Hatfield and are one of the largest consumers of water in the area. However, they are not optimally utilizing a circular water system. For example, 160 million liters of water is used on the Hillcrest campus and none of it is recycled. Both stakeholders are looking to improve the user experience in Hatfield. This goal can be achieved by improving water systems, which improves the urban fabric. The problem state. We have been bombarded by the media so much that Hatfield is now seen as a hyper-urbanized, water-scarce place. But the reality is that Hatfield has an abundance of water as well as some spaces that do interact with nature, but is not considered due to its inaccessibility. We would like to address this disconnect and shift the perspective to not only what Hatfield is, but what it can become. The current linear water system starts off with a collection of water through natural streams which flows into a man-made reservoirs where it is stored. Filtration occurs both mechanically and chemically before the water is distributed through the rainwater pipe system. Water becomes waste through leaks from unmaintained pipes, and at the site scale, water is wasted according to the behavior of the users on each site.
The target state. We would like to tap into Hatfield's perception and identity. Are we really water scarce? Tshwane is actually water rich, but it is separated from that identity. Our intention is to make third places for water to be celebrated. In other words, to expose the water and let the invisible be celebrated. The proposed circular system introduces wastewater back into the water cycle, therefore turning wastewater into a resource. Instead of water being discarded after the consumption stage, it is sent to the wetlands in a system that mimics a more natural setting. Rainwater harvesting systems, namely green roofs and bioswales, are used to increase water collection. Clean water is then reintroduced into the system after biofiltration has been completed in the wetlands. The Sheffield Green Street project is a medium-scale intervention that manages stormwater while enhancing urban biodiversity. The shaded walkways, pedestrian bridges, and public seating incorporated into the design contribute to an improved experience of the space. The sponge city concept was coined in China, and we have examined it as a successfully implemented large-scale intervention. We were informed by the transformation of the wetland components into public spaces by encouraging visual interaction through raised walkways. Our proposed intervention can be measured against the ecosystemic services theory that emerged in the 1970s. These include regulating, provisioning, cultural, and supporting. Our intervention will regulate itself, not only through natural regeneration, but also through environmental education to the users, who will contribute to the space's livelihood. There will be provision of food and fresh water for both people and animals through edible plants, fountains, and ponds. It will give people a place for recreation, relaxation, and cultural expression through the creation of third places. It will further support the larger ecosystem by improving air and soil quality, as well as increasing the likelihood of rain. It will improve the local climate and will contribute towards counteracting global warming. We would like to achieve a circular zero-waste city in regard to water resources, and these are the systems to support that. We looked at grey water and how that can be reused in the buildings. Grey water contains both organic and inorganic contaminants, such as soap and detergents. It goes through a fairly intensive 5-step filtration process to make sure it meets safety standards. Next, we have brown water treatment, which is a multi-step process that produces recycled water for non-potable use and has the potential to produce power and fertilizers as byproducts. We intend to line the streets with bioswales that help to clean and transport the water to our constructed wetlands for further treatment. The planting palette will largely consist of robust native plants. The water is treated in the wetlands through biofiltration and is sent back to the buildings and parks for reuse. While the wetlands themselves recharge the groundwater systems, managed aquifer recharge can be used to supplement this. The challenge state. Looking at the physical attributes of Hatfield, such as existing systems and contours, alongside movement patterns and sidewalk conditions within the zoning context, we can clearly identify areas that overlap. These zones will inform where our intervention is needed most and how we'll approach it moving forward. Looking at our identified possible intervention zones within the context of Hatfield, we start to conceptualize how we want to address the disconnect in Hatfield by linking our spaces by means of intervention to the existing natural environment. This aims to create a uniform view of Hatfield. Zooming in on the first intervention zone, we start to conceptualize how we want to link Hatfield and Hillcrest campus through our intervention by means of a multi-level central corridor. The main sites along the central corridor framework are Hillcrest campus and Hatfield campus, with Belgrave Park situated as a central point. We intend to contribute to the positive perception that these spaces currently have in Hatfield by enhancing the network connecting these spaces.
The central node of our intervention brings together a diverse collection of users moving throughout the site. The site is, however, not comfortable for the user due to the Jan Schober Road, a high traffic road which does not include optimal intersection spaces for pedestrians. This hampers the safety of pedestrian movement across the road. The utilization of space currently consists of commercial spaces with parking facing the street. This does not allow for comfortable transition spaces along the street edge. To cultivate functional urban space, we address the street intervention by softening the pedestrian crossing, widening the street edge, and incorporating planted buffer spaces which provide space for a safe and interactive transitional space along the street edge. This will lead to a more functional public space with commercial and recreational activities and an overall improvement of the microclimate and aesthetic appearance of the sidewalk zone. Enlargement of the planted buffer zone between the street edge and the built structures creates space for interactive spaces such as meandering walkways, restaurants, commercial stands, and public seating. This draws a more diverse range of users into the space, slows down the pace of dynamic movement spaces into passive, lingering spaces. Interacting with spaces lower and higher than street level experiments with alternative ways for users to move through the site without obstructions by vehicles, and thus transforming the crossing itself into a functional space. Expanding sidewalks and creating a central sidewalk along Jan Schober Street allows the users to move along a space which feels protected from vehicles on the street edge. Hard surfaces are converted into permeable surfaces, allowing for an increase in water infiltration.
The current urban landscape of Hatfield largely operates on a two-dimensional plane. Private stakeholders developed vertical expansion, such as the Javed Art Centre, where programs such as underground parking, public courtyards, galleries, pedestrian walkways, and roads are laid on top of one another. It is vital for the public realm to expand vertically to ensure efficiency of the complex programs within a city.
The movement of water throughout the site is celebrated through the exposing of the biofiltration system. The prioritizing of natural systems leads to increased biodiversity. This automatically leads to the creation of surrounding public spaces, which have the necessary environmental features to improve user well-being. The system begins at the street level, where stormwater is collected off the road and sidewalk. Holding points slow down the movement of water into the wetlands. From here, water is reintroduced back into the distribution system. Here we have our iteration process of how we can apply our desired system spatially. We made use of various techniques and started exploring mass and geometry. The project begins with connecting the space along Prospect Street to create our development zone. The restoration of the existing built space into open green space allows for the establishment of the biofiltration system throughout this open space. In the second phase of the project, a pedestrian walkway is introduced, which draws users through the space and encourages reflection on our connection with the natural environment by exposing the users to natural water systems. The final phase of the project is the expansion of the space in the vertical plane by breaking up the space into various levels. This allows the user to experience the space through various lenses. The opportunity is provided to the user to experience an encompassing view of their surroundings from the raised pedestrian walkway. As the user moves from the peripheries of the space towards the main wetland feature, the organic forms create a diverse assortment of spaces, from exposed courtyards to covered market spaces. This space feeds into the wetland, where users interact with it through platforms at various levels. The main entrance is at the corner of Prospect and Grosvenor Street, where we factored in a drop-off zone. We also have a multifunctional space that will primarily house temporary pop-up markets and has the potential to evolve in the future. The picnic space is zoned as a semi-private space where people can sit and relax, but still enjoy the view of the wetland. Sidewalk conditions favor greater user interactions with the space. We have interactive educational as well as interactive program spaces where people can learn more about our proposed systems through lived experiences. Sports courts and fields are proposed as an inclusive recreational element, which connects to the already thriving culture of sports and recreation in Hatfield. Currently, at the intersection of Jan Schober and Prospect Street, the space is monofunctional. It is dominated by hard-surfaced parking spaces. In the future state, these hard surfaces will be replaced with permeable blocks and green surfaces that allow for greater infiltration. Currently, Belgrave Park is fenced off and caters only to a select group of users who play sports. In the future, this space will be opened up to be the defining point of our filtration system, our wetland, which will become a thriving social hub as well as a functional stormwater drainage system. The Raindrop effect is a project that will send through ripples of impact in the Hatfield community. Thank you for your time.